spot now, so hopefully that'll be better.
Yay!
We'll see.
Alrighty. Now, okay, back to the test, right?
Okay. And that I have loaded now.
All right. Thank goodness for hotspots and other things.
Yes.
Okay. All right, how are you doing? You ready?
Yeah. I've got it open now.
Okay, question 2. If I remember right, this is like 26 questions, isn't it?
I think so.
27. All right, so we're going to crank on this. We're going to do so good. All right.
We got this.
We do. Given a 90% confidence level of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? 1, we are 90% confident that the true mean heart rate is between 45 and 105. There's a 90% chance that the true mean heart rate is between 45 and 105. 90% of all people have a heart rate between 45 and 105. There is a 90% chance that the sample mean heart rate is between 45 and 105.
Isn't it the first one?
Yes.
Okay.
Yeah, they said it's not a chance, it's not a guess, it's just a confidence level. So it's to me, I look for that word of we're confident. Yeah, when it says chance and guess, and I'm like, no.
No, it's in there. That's what it is, right?
Yeah, we're hoping it's in there.
Hoping.
We're confident that if we did this test, 100 times, that 90% of the times the true mean will be in there, is what we're saying, if I got that right. So.
Okay.
Okay, carry on.
Researchers at University of Mississippi want to determine whether the reaction time in seconds to go/no-go stimulus for males differs from that of females. The researchers randomly selected 20 females and 15 males to participate. The go/no-go stimulus required the student to respond to a particular stimulus and not respond to another stimulus. The researchers decided to construct a confidence interval to determine if the difference of the mean is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and
she's gone. And see that they are randomly.
They are proximal.
Okay, you are totally disappearing. You just came back.
Okay. Yeah, I could hear you and then I couldn't.
Okay. Well, I wasn't doing much talking. Okay. To determine whether confidence level is reliable, they create random samples. Let's see the approximately normal. Are the requirements for the confidence level satisfied?
Well, is the sample size large enough to determine if it's, because it's only 20 females and 15 males?
No, which is why we went to the QQ plots to see if they're randomly distributed, which they are. It says they're approximately normal. And it does say that they randomly selected, so we know that they are a simple random sample from the population. So we do know that they're a simple random sample and that the distribution is normal. So therefore, I believe that the requirements are met. You think so?
Yes. So is it?
I think it's the second one. Yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yes.
Yeah. Okay. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Okay. So this experiment to me is, it's a 2 means, but it's independent samples, because The only thing we know about the ones who were picked determined to the other one, well, one, they're two different sizes, so they're not paired. And two, just because they picked females and they picked males, there's no relation to each other. So
Yeah.
so that by knowing what kind of test we're doing, then that tells us what our confidence interval is, what our hypothesis should look like. So confidence. Oh, using independent samples. Hello, I just answered that without realizing it. So,
Yeah. Oh, good, Lisa.
Confidence interval for the difference of means using independent samples. Da, 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 da. I guess I understood that, huh?
Yeah.
Okay, your turn.
Okay. A researcher is interested in estimating a savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of the customers is found to be 3,402.08, and then 42.75. Which of the following would produce a confidence interval with smaller margin of error than 95 confidence interval? Wouldn't it be a smaller margin of error if they had more? So like the second one, if they obtain 90 bank customers rather than 30?
Let's see, what was that? That was the yeah, the more that you have, then the margin of error should be smaller. It would be closer to the means. I can't remember, what is that? It's not central limits theorem, that's the, is that the law of large numbers? Something like
I think
that.
so.
Yeah.
I just knew that. So would it be obtain the balances of 90 bank customers rather than 30?
Random sample of
I don't
30.
know. That's the one that makes sense to me.
It's found to be just a confidence interval with a smaller margin of error. Well, yeah, you would need to have more.
Mm-hmm.
Yeah, you would need more. Not only 10 customers rather than 30, 10 the balances of 90 customers rather than 30. I agree with you on that.
Okay.
That would be interesting because, you know, the more bank customers also that you're gonna get some that have the $10,000 and $30,000 bank accounts.
Yeah.
And you're gonna get those that, you know, were like me forever and ever, that, you know, I was lucky if I had $50. So so much fun. All right. A factory makes propeller drive shafts for ships. Yeah, I can say that really. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects, man, I am tired. Okay. 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Okie dokie, I think we've
Okay,
got
and I have this one done. This is one of the questions I did. But I should probably make sure that I did it right.
Or make sure I can do it.
Okay.
All right, paper. Where are your paper? Okay, so what we need to do then is to come up with a margin of error, correct?
Yeah, and for the 95, it's 1.96.
Oh, God, I forgot all
I was
about
smart
that.
enough to write all those down.
Okay,
earlier.
I wasn't. Thank you for that. That needs to go in my miscellaneous. Okay.
Yeah.
All right. Think, Lisa. Where's my brain? All right. Which formula did we want then? What formula do we want on this? I'm so confused.
Isn't it the one for margin of error?
Okay, so that would be 2 times the sigma over the divided by the number in the sample. That gives us our margin of error, right? Okay. And this one, oh, think, Lisa. Sigma is, what the heck is sigma? That's
It's going to
so
be 2.
That's our standard deviation, right? Okay,
Yeah.
so that's 2
Yeah.
divided by
The
the
square root.
sample size, which is the square root of, where are you, sample size? Wasn't it
It's
4?
going to be 4. They wrote it out. Yeah.
Oh, that's
It confused me earlier because I was like, oh, where is it? And then I was like, oh, they wrote it out in letters.
Oh, did you get the actual answers thing for this? Or
yeah, I've got my answer for it.
okay,
I worked it out.
Dun, dun, dun. Let's see, square root of 4. Oh, duh, like I shouldn't know that, right? So 2 divided by 2 is 1, is it not? So 2 times 1 is 2. So isn't the whole answer 2?
I got 1.96.
I'm so confused. All right, if I'm doing this, I know we've done this. We've done this plenty of times, and I should know how to do this.
Oh, yeah.
2 divided by the square root of 4 is a
Well, it's
syntax
going to
error.
be 1.96 times 2.
Wait, where am I?
Divided by.
Where am I getting the 1.96 times 2? I'm
because that's going to be the 95.
I'm trying
confidence.
to find where I wrote this
The formula.
Formula, yes. Somewhere.
It's in lesson 10, if that helps.
I didn't write the formula down here somewhere, so which would be, so it would be the confidence level, right? Confidence level times, is it times the mu? I mean, not the mu, times the sigma divided by the sample size, the square root of the sample
the square root of the sample. Yeah, there it is.
Okay, so I'm totally an idiot. We'll do this 1.96 times 2. I'm going to go with the just 2. Right, so okay, my answer comes out to 0.255. Is that what you got? As
I got
far
1.96. Here,
well, I thought we
check.
We did the 1.96 times 2, right? And then that's going to be divided by the square root of 4.
Mm-hmm.
And you still came back out with 196?
Yeah.
Okay, so I'm going 1.96 times 2 gives me 3.92. Wait, how did I do that? Lisa, get your freaking head on. I don't know where I got that number already. I got some really strange number to begin with. I'm going to go to bed after this. I'm not taking this test tomorrow. Okay, divided by 2. Okay, yeah, okay, 1.96. Hello, duh. I figured out how to get there. Amazing. Too bad I can't just have you here on the test, right? Okay, so if we're going to take the 1,000 millimeters, and then we're gonna minus Oh, wait a minute. We're going to minus 1.96, correct? And we get 998 on the low, and then on the high would be 1001.96, right?
Yeah, I got 998.04 and then 100196.
So that would be the first one, correct?
Uh-huh.
Okay. All right. I need to write down the confidence levels. Well, it's for 90 and 95 and 99. That's the ones we used most often, wasn't it?
Mm-hmm.
So it's 1.96. And did you write down the 90 and the 99?
Got them in a... Okay. So 90 is 1.4... Or no, don't listen to me. 1.64.
That sounds
And then
familiar.
99 is 2.576.
Okay. All right. That is on my notes. All right. Awesome.
Okay.
Awesome possum. All right. Okay, my turn to read or yours? It took me forever.
I can read.
Okay.
To access the accuracy of a laboratory scale, a standard weight is known to weigh 1 gram, is repeatedly weighed a total of n times, and the mean of the weighings. It's weird. My brain was like, I'm not computing. Is computed. Okay. Suppose that the scale readings are normally distributed with an unknown mean and a standard deviation of 0.01 grams. How large should the n be so that the 95 confidence interval for nu has a margin of error of 0.0001?
Really?
Yeah, and I actually
Okay.
looked up this formula.
Let's see. I think isn't that the one n equals, and then we've got z times sigma over the margin of error, and then that whole thing is squared?
Uh-huh.
Okay. So I wrote that one down. I just haven't done it in a while. So we'll plug in what we've got.
Yeah, after this I'm past what I've done, so.
Okay. Then we are totally, okay. Let's see. So our z score, let's see. The mean area is, oh wait, wrong one. Okay. Normally registered with an unknown mu and a standard deviation, okay, is point. All right, Lisa, I keep losing this. 0.01. Okay, the confidence interval for mu has a margin of error of plus or minus. So the margin of error, we're going to put 0.0001. And what in the world is our z? Wait, is that?
It's going to be for
so
the 95 confidence interval, so it's going to be 1.96.
The 1.961.
Or at least that's how I did it.
Yeah, that makes sense. Okay.
Mm-hmm.
All right. You're taking me back a couple weeks here. This is just nuts. Okay. I know I understood it when we did it.
That's why we're doing this. It's a review.
Yeah, hallelujah. Okay. Okay, so I want that answer, and it's going to be divided by 0.1231 equals 196. And then that is going to be squared, right? Yeah, okay, where is my square? There it is. Take that. Okay, I got 38416. Is that what you got?
That's what I got.
Okay, and that is one of the choices, so that is encouraging.
Yeah.
Okay, third one down. Alrighty, yes. Okay. The mean area of mu of the several thousand apartments in a new development is advertising to be 1,250 square feet. How nice. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis for mu
It's gonna be
are.
the it's gonna be the third one, isn't it? Because they want to see if they're smaller.
That mu
Right?
is.
No, wait, no. It's the first one. Got my signs mixed up.
Okay, the mu is that they're equal.
It's less.
And the alternative would be that that the mu is actually smaller than. So yes. Yes,
So
I
the first one,
believe
right?
the first one is correct. Okay.
In a statistical test of hypothesis, we state that the data are significantly different at a significance level of A if.
Oh, wait, I'm sorry. In a statistical test of hypothesis, we say the data are statistically significant at the level of significance alpha, right?
Yeah.
So the data is significant at the level of significance. If, okay. Okay, if the p-value is larger, then we are not rejecting the null. We are keeping the null. If the p-value is less, then we say that there is evidence to reject the null, correct? So
Yeah.
then shouldn't it be that the p-value is less than it's a level of significance? It's significantly level, there's a significance for us to reject if it is less than alpha, correct? Does that make sense?
It did for a minute, and then I lost it. So you see that? Because if it's low, we reject the null, right?
Correct. Right. So that is
Okay.
if the p-value is less
And if it's
than the alpha, then we reject,
okay.
right? So that's saying that is
Yeah.
that's showing a significant difference, right?
Mm-hmm.
So the data is statistically significant at the level of significance if the p-value is less than.
Yeah, I agree. I think that's it.
Because you can pick the fact that it's 0.05 doesn't mean anything because you pick that before you do the test.
Yeah. Well, and it can be any, it doesn't have to be 0.05
no,
level of significance, right? Because it's been other things.
Yeah, and when it just says that the alpha is small, that doesn't mean anything either. So what? Mm-hmm. It's what the alpha is compared to when it's compared to the p-value.
Mm-hmm.
But if it's larger, then it's not significant enough for us to reject the null. So then, anyway, yeah. I'm talking myself into my answer.
No, I agree. It makes sense. I just had to rethink it in my head.
Thank you for listening to this. Okay, a group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. Okay, so who lives in the party apartments? Woohoo! Mm-hmm. They collect GPAs. Sorry. I am losing it. From an anonymous random sample size of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can you use an ANOVA hypothesis to test to answer their questions? Okay, if the variances are equal, and we know that each one is normal. So if they're bell shaped, they would be normal. So then those are met, right?
And there's no outliers.
Yeah. And the sample variances are nearly equal. They do not know the true standard deviations of each sample. So what? That's what we use the ANOVA limit for. It tells us. I would say yes, the first answer.
Okay. Makes sense.
I hope I'm right. I hate to mess this up. All right, your turn.
A medical researcher is working. What was that?
Carry on. Go on.
Oh, okay. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed a type 1 error, a type 2 error, incorrectly used a 0.05 significance level where she should have used a 0.01 significance level, incorrectly used a 0.05 significant test when she should have computed the p-value.
She committed a type 1 error. She rejected the null when she should not have. Let me make sure. Let's see. Did I write that down somewhere? No, but I remember going over that yesterday. So type 1 is when you reject the null and you shouldn't have. Type 2 is when you kept the null and you should have rejected. So it's a type 1.
Make sure we put that.
Okay, 12. If the level of significance, alpha, is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? It gets larger. Okay. Oh, that's the last one. By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error. So I'm just going to answer that one.
Sounds good to me.
Okay, 13 Jew.
The nicotine content in cigarettes of a certain brand is normally distributed, with mean in milligrams, and known standard deviation of 0.17. The brand advertises that the mean nicotine contents of its cigarettes is 1.5, but measures on a random sample of 100 cigarettes of this brand give it the sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this question, test the hypothesis.
Okay.
And
they're saying that the alternative is that the mu is actually larger than. Okay. Okay, so the first thing we have to do is we have to get a z-score, yeah?
Yes.
Okay, so I know I've written that down here. So we're taking our X bar. Where are you, X bar? That's 1.53, right? Minus the mu of the 1.5. And then that's going to be divided by our sample size is 100 and our, okay, where are you? Standard deviation is 0.17. Okay, got my numbers in, now I can play.
Okay, if I remember correctly, it's so it's the 1.53 minus 1.5,
Right, which would give
and
us,
then we divide by the standard deviation, and is it this? And that's divided by this.
okay, we're going to
I'm
divide by
trying to remember.
the standard deviation is divided by the square root of the population, or of the
Okay,
test
that's what I
size.
thought.
Yeah.
So it's going to be.
So we're going to
This is
take the
standard.
0.17 is
17
divided
and
by
divided
the
by.
square root of 100.
Okay. I just needed to make sure I remembered how to do that.
And since my calculator is stupid and won't let me string it, I have to do that in steps. Actually, I shouldn't say the calculator's stupid. It's just I don't know how to put it in.
Gotta make sure I put my points in the right place.
Yeah, that's messed me up a few times. Okay, so then we're going to go to the probability applet, which I have open, yes. And I'm going to plug in this z-score. 1.764.
That's what I got.
1.765, basically.
Oh, yeah. And we put that for the area, right?
No, that's a z-score. It goes in the z-score at the bottom.
Oh, z-score. Oh, I should use my brain. That's probably.
Nah, it's overrated. Sorry.
Okay.
Okay, so let's go back here. And what is our question? Okay. At the 5% level of significance, you conclude that you should.
And it's only going to be one-tailed, right?
It should be one-tailed. You're correct. So therefore, we're going to take our area and divide it by 2. Okay, so we're going to take our 0.0776 and divide that by 2. So I'm getting a 0.038. So basically a 0.04, which would be less than our level of significance. So therefore, we shall reject
the null. So the last one.
Yes. Oh, aren't they getting tricky putting up their reject the alternate? You really got to look and see if that's an and.
Goodness.
Oh, with my glasses, good luck. Okay. Ew, I'm impressed with us. We did it. Okay.
Yay. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? One sample z-test, one sample t-test, pair sample t-test, independent samples t-test, or ANOVA.
My personal opinion, that's an independent samples t-test, because just that they're male and female, but other than that, they're not paired. You may want 100 of. It says you would like a random sample of 100, but that doesn't mean that you'll never necessarily get it. You might get 99.
Yeah.
Just because the sample size matches, I don't think that makes it a paired sample. That's my guess. What do you say?
I agree.
And
just like by what you said, by like the male and the females, like they're going to be separate samples.
Yeah, we may get their same info from them, but other than that, because if I remember right, the difference for the thing for a paired is that
like they go together.
The first group depends on who the second group is, or they're connected. And this one, they're not connected, because it doesn't really matter who the guys are you ask compared to who the girls are. I think they're being tricky by giving you the same size. Okay. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. That does not mean they have the same academic support, just saying. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. That's quite interesting. Should she use a hypothesis test based on independent or dependent sampling? That would be dependent sampling.
Yeah, because they can't just like pair any brother and sister. They have to be from the same family.
Well, they have to be in the same. Yeah, because if you're going to do siblings, right there, they're attached. Because who you select depends on who the other one is. So that's dependent. But just saying that there's so many families that think that, brothers should go to college because they're going to support, and women should stay at home.
Yeah.
That does not necessarily mean that they have academic support systems that are the same. That hypothesis is right there, blown out of the water.
Yeah. Is it going to be the last one then?
Yes.
Because if you select the brother, yeah. You must include the sister. Okay.
Yes.
A soil test collected random soil samples from a field and measured and dissolved organic carbon level for each sample. The research would like to construct a 95 confidence interval for a mean dissolved organic carbon level in the field. Open the data file. To answer questions 16 to 17.
Sorry, I like the sound effects went with that so nicely. Okay.
Okay, I'm gonna open that.
Wait, what was the name of that file I'm supposed to open? Oh, dissolved. I was going for organic and couldn't find it. It's dissolved. Organic. Okay. Dissolved organic carbon. There you are, baby. I wonder if I can go through and delete all of these out of my computer later, because there's so many downloads. Unbelievable. Okay, you're taking up space. You're out of here after this class. Okay, why are you not opening?
You're not gonna need them after, anyways.
Yeah, I don't think I need to know all the information for diving elephant seals. I just don't think it's going to be relevant there. That just happened to be the first one my eyes went to. Okay. Our gharial crocodiles. There you go. That's something I talk about every day. It's being very slow in opening. Are you open?
No, it's slowly opening.
It doesn't seem that it's enjoying to have all these windows open.
Mine was acting weird yesterday. So, well, not yesterday. Today, it was being weird.
All right, we are finally there. Well, it's only one set of data, so that's interesting to know. Note. All right, let's close Google over here. I don't need you. And our question then. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? Confidence level for the mean.
You still there?
Yeah, I'm
Okay.
trying to get, okay, so
It just got really quiet in my SPS. This is being weird.
okay.
And I can't open. My internet in it is being dumb and I can't open it up.
Oh, that's not cool. Well, we can play with mine then. Okay.
Okay.
I'd like to construct.
I really hope it works when I'm taking the test.
Yeah, that would be helpful, wouldn't it? Okay, this is not telling us that mu is that the mean of differences using. Okay, this is not dependent, and it's not a difference of means using independent. So those two are wrong. And I'm saying we don't know what the we don't know sigma, correct? Yeah, this doesn't give us what it is. So I would assume that the confidence interval for mu when sigma is unknown. That would be my. I don't know why we needed to open that for that question.
Okay, I was like,
that was kind of lame. I know. What do you think? Am I thinking of this wrong?
I think you're right.
Well, because we can't do a mean of differences because there's only one row of data. That's it. And it's independent samples. I mean, again, we only have one group of sampling, so what does that matter? We're not comparing. Random soil samples from a field. Yeah, he's just taking it from one field. Okay. And they didn't give us that we have sigma. Okay. Which of the following is the 95% confidence interval for these data? Okay, that's why we had to open it. All right. There we go. Okay, so we are going to analyze descriptive statistics. Okay. All right, just. Oh, that was the wrong one. Shouldn't have done that. All right. So we're going to go analyze descriptive statistics and explore. I should have done explore. Okay. And then that gave us our upper and lower. Oh, I'm sorry. I'm not even telling you what I did. Big fat mouth.
Oh, it's okay. I am still trying to see if I can pull it up, but
okay. What I did is I went to analyze, and then descriptive statistics and explore, and then that gave us the mean, the 95% confidence interval for the mean, and that gives us our median, our variance, our standard deviation, and all of that.
Okay.
So that's what I went to. So, and I got 11.168 for the low end and 15.217 for the high end, which would be the last choice of number 17.
Well, that is on there, so that's good.
Okay. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. I used to always want a Hummer. Anyway, we want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles, which is group 1, and Hummers for sale in New York, group 2. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. Open the data file and use data file used Hummers, LA and New York. Okay. Okay, the first question is, of the 4 types of confidence intervals listed below, which one's appropriate? And whether it's a confidence interval for a mu when sigma is known, confidence interval for mu when sigma is unknown, confidence level for the mean of differences using dependent samples, or confidence interval for the difference of means using independent samples. And I believe that it would be the last one, confidence interval for the difference of means using independent samples, because we need to take the two and then subtract one from the other to find out the difference, and it's the mean of the difference is what we're going for, because we want to create a 95% confidence interval for the true difference, the difference of the mean listing prices.
Mm-hmm.
So that's why we're going for number 4. Okay. Just saying. Oh, wait a minute. Get up here, please. Thank you. And now I want to get rid of you. Close it. Yes. Save.
I got it.
Oh, and now you disappeared. Rats. I hear you again. Did you get it up?
Yeah. Okay, so it's analyze, descriptive.
It was number 17. It was the last one. Sorry, I'm trying to open up now. I'm trying to open up the used Hummers in New York and
no, it's
LA.
okay.
Which is taking its sweet baby time. Man, doesn't sound like my husband's home yet. Okay. Alrighty. Okay, let's go back over to our next question is, which of the following is the 95% confidence interval for the true difference of mean listing prices of Hummers from LA and New York? Okay, so if I remember right, the first thing, we don't care about the year. We don't care about the model. We know the Hummers. We don't care about that. What we care about are the dealers, which is Los Angeles and New York. Okay, so I think first thing we have to do is we're going to transform. I'm sorry, am I losing you? Okay, where's my... Okay, transform. Okay, compute variable. That's what we're going to do. We're going to compute the variable.
So wait, we're not going to automatic recode, or am I? No. Compute variable.
Because we just want group 1 and group 2, so we're going for... Is it city, right? LA or New York?
Yeah.
Right? So we want that into... Oh, no, wait a minute. No, wait a minute. I'm wrong. Okay. We need to recode. I'm getting ahead of myself. Compute variable is once we've already got it. Never mind. I shall close that baby out. Okay, so transform and let's go to automatic recode, and then we'll do that for the cities. Yeah. And so then we want to change that name. Code. Okay, Los Angeles 1, New York 2. Okay. And then we're going to transform and compute variable, our target variable. Differ. Okay, we have to put a name in the target variable because remember we're making a new
Yeah.
list just because I forgot. So
Okay.
Now I'm getting totally confused.
Because somehow we need to subtract LA and New York, right?
We do. But how do we get that into the type and label? I'm trying to remember how to do that. Transform auto recode, move the variable, and create a new name. Okay, analyze. Two means paired. It's not paired though. La 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 la. Okay, let's get out of here for a minute. Take you back. Okay, seller is dealer individual, so we don't want that. Okay, we've done this to 1 and 2. City code has been changed. Okay. Trying to remember how we did this. Analyze. Ooh, do we go to compare means to independent sample t-test? I think we do. Because then we want city. Okay, we want price as our test variable, right? And then our group variable is going to be the city code. And then we need to define groups, which is 1 and 2. Got it. Did I lose you?
No, I'm following right along.
Okay, and okay. Okay, so now what's our question?
I was like, now what was the question?
I got the information. Now what did I want to know?
The 95 confidence interval.
Okay.
Of the difference of mean.
Okay. Okay. Oh, wait. No, don't disappear on me. The heck did you go? 95% confidence. And if I remember correctly, we always take the bottom row of numbers because, okay, so that would be -423.158, and the upper is 5417.256. Okay, so I'm getting 423 and then 5417. So that would be the third one down, which is what I got. Is that what you got?
I got the same thing.
Okay. Man, that was a little fun trying to figure out what the heck I was doing. All right.
Okay. Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined that the effort of jumping on the bone density of growing rats.
Okay, I want to know, how the heck do you get a rat to jump?
I don't know.
Okay, carry on.
There were 3 groups. Rats were selected at random for the 3 groups. A control with no jumping, a low jump group with the jump height of 30 centimeters, and the high jump group of 60 centimeters.
Okay, do you just drop the rat on a trampoline?
I'm just seeing these rats jumping, and this is interesting.
I have not seen a rat jump unless it's a kangaroo rat, so just saying.
Yeah.
And all I can say is when they're going 30 centimeters and 60 centimeters, okay? Do you know how high that has to be? I mean, 30 centimeters. We're talking that's like almost 10 inches. I want to see a rat jump 10 inches if you're not dropping it on a trampoline. Okay? Because rats don't jump. How do you make a rat jump? That's just ridiculous. Okay. Yeah, I would have to point that out, right? I'm not tired. All right. After 8 weeks of 10 jumps per day. Sorry. You better read. Keep going.
Okay, 5 times per week, the bone density of the rats expressed in was measured. The rats were selected at random for the 3 groups. Researchers would like to determine if the means of bone density are different between the rats listed above. Use the 0.05 level of significance. Open the data file exercise bone density. Use this information for questions 20 through 23.
Okay,
what is the correct hypothesis for this situation?
Okay.
Is it a one sample z-test that? Oh, go ahead.
No, I was just going to say we have 3 samples of rats, right? So we can't do anything that's one sample or paired samples. We need to go to ANOVA right there. That's
sounds good.
Okay,
and then we need to calculate the test statistic.
Yeah, let's go to those jumping rats, baby. Okay. I think they bounced rats. I dare him to watch this and not laugh. Okay. Was it bone mineral data? Is that what we were going to?
I don't remember.
I don't either.
It's exercise bone density.
Oh. Dang it. Okay. Let's see. Have to get rid of the old one because it doesn't like to have 2 of them open at once. All right. Exercise bone. Watch him make us open that on the test, and I'm going to start laughing. I spent spent 4 hours laughing at your bouncing rats. Oh.
Sometimes I wonder if these like are real studies or if they just like totally just made them up.
Oh, guys, seriously? I want to ask that one. I want to put that in the question answer. Did they really, really try and make rats jump? There's a high jump. Oh yeah, can you see the bar now? Yeah, I'm gonna jump. Oh, I wonder if the rats actually had to jump over a bar. You know, like a high jump and a low jump, like in track.
Oh my goodness. Oh.
Oh,
Oh,
okay.
that
I'm
was
getting
something.
far too entertained by this. Okay, I just know right now we're gonna have to transform the data, so let's just go there already. It's just automatic recode because you know that's gonna happen. So treatment is what we're recoding. Okay. Okay. All right, now I can go back over to the questions. All right.
It was test statistic, right?
Calculate the test statistics. Yes, calculate the tests. I can't even speak. Alrighty then, sure I will. Okay, so we're going to analyze, and he always says do descriptive statistics first.
Come on.
Because, and so we want
And then
density is going over, and then treatment code goes into the factor, right? And then we're going to go to options. No, we're not. I was kidding. Okay. And then I'm going to go back over to analyze and compare means. And then we're going to go down to the one-way ANOVA. And so we're going to put their density in the dependent list. We're going to put treatment code in the factor. And this one is where we're going to go to options and put descriptive and a means plot and a continue. And okay. So now, what did they want?
calculate test statistic.
Which would be an F. So that's 7.978.
Hold on. No, when I tell you to move, that would be nice.
All right. Okay, and then next one we're going for the p-value.
Okay, hold on. Okay, so F is 7.978.
Correct.
Okay, all right. Just took forever to get to that. Good grief. Okay, and then give the p-value.
Correct, which is the sig.
So the 0.002.
Correct. Yes, that's what I got. Okay. Which of the following best expresses the conclusion of this test? Use a level of significance of alpha equals 0.05. So there is sufficient evidence to conclude the bone density of all three groups is about the same. I'd say no, because it's small. So there's at least one of the groups is different from the bone density of at least one of the other groups. Yes. I would say yes on number 2. There is sufficient evidence. We could go back to the plots and look, but I don't really care. Alrighty then.
Wait,
Okay,
why is that?
I'm
Isn't
sorry.
it
What's
that we
not
would
what?
reject? Well, why is it the second one?
Oh, well, because when we write it out longhand, so yes, we are going to reject the null, right? And when we
Yes.
write that out, the reason we're rejecting the null is because there is sufficient evidence to conclude that the bone density of at least one group of the rats is different from the bone density of the other groups, of at least one of the other groups,
Okay.
which doesn't make any sense. This should say the other groups.
Okay.
Okay. All right, there's a dumb part of me that I actually want to go see. Oh my. What a huge difference. There really is a big difference in the difference of the bouncing rats.
Mm-hmm.
I just had to go look just for the fun of it. But which ones? The high jumps did much better than the low jumps, but even the low jumps were much higher than the control group. All right, now that I don't care, but I had to look anyway.
Why not?
Okay. Yes, save the changes now. All right, they're gone. All right. 24. We're almost there. Yay. Okay.
Yay.
Pressures of supply and demand act differently on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. No duh. If seats on a flight do not sell well, and an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there's a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. That's a lot of checking. Perform a yes, I will perform a hypothesis test to determine if there is a difference in the cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance, alpha equals 0.10. Open the data file, direct flight costs, and use this information to answer questions 24 through 27. We've used this file before. Just saying. Alrighty.
Okay.
Direct flight costs, which means it won't be downloaded to my computer yet again. Waiting. I think we have 4 hours to take the test just so these things will open.
I agree. They take forever.
Okay, so all our origins are okay, our destination. So what we're comparing is the 14 days to the 90 days. Correct, Amanda?
Mm-hmm.
We want to know the difference between the two. So we're going to go with, this is an independent study test, yeah?
So the independent samples test for 24?
That's what I think. It should be independent samples t-test. Yeah?
Mm-hmm.
Because we haven't done a summary independent samples t-test, have we? No.
I don't think so.
No. We've done everything but the summary. Okay. So we're going to take, do we want 14 minus 90 or 90 minus 14? I think I'm going to take, oh no, wait.
Is this in compute variable? Do I have this right? Or am I doing this wrong?
I went to the wrong one. Okay.
Okay, because that's what I did, but I'm not sure.
Okay, so first we have to transform to compute variable. So I messed up there. All right, so who are you having subtracting who? I'm going to take
I
14.
put 14 and then 90.
14 minus 90. That would make sense to me. And then we're just going to, what did I miss? 14 minus 90. I've missed hitting something here because I can't hit OK. Oh, target variables. I didn't put that in.
Yeah.
Hello. Okay. That would be my problem. Okay. Thank goodness there's checks and balances here. Okay, so then now we can go to analyze, right? And compare means. And for is it independent samples now? I'm so confused. Or is it a one sample t-test? Oh, now it confused me. No, I think we go to one sample on this, yeah?
Yeah.
Because we're now using just the one group, right? So the one sample t-test. Or is it paired? No, it wouldn't be paired. Would it? Yes, it is paired. It's paired because...
That's not one of the options for 24, though.
No. All right, never mind. I'm getting ahead of myself. Why don't you just get over to the questions and see what you need, Lisa? Shut up. All right. What is the correct hypothesis for this situation?
That's the one sample mean? One sample T, right?
I think it is going to be a one sample T.
I think so too.
Yeah. Calculate the test statistic. And that's where I was messing with myself. Okay.
I got 1.685.
One sample T. And I'm going to go with the differences. Yeah. Did the test variables. Test value. Did you put the test value in?
Oh, no, I didn't. So maybe I need to redo this.
But do we have anything that tells us what the mu is? Because the test value is going to be what the mu is in the hypothesis. And so the test value could be 0 because the hypothesis could be.
Oh.
Okay.
Okay. All right.
No. Test value mu. Okay. Because we just want to know if it's different, right?
Mm-hmm. So.
But it doesn't tell us what mu is. So I think we need to actually go down to I am so confusing the bejeebies out of me. 2 means paired data? Huh. I'm confusing me. I am easily confused here. Variable 1 would have been 14 days goes to variable 1. Variable 2 would have been 90 days, right?
Mm-hmm.
Okay. All right. Yeah, I'm saying that, yeah, these must be a paired one, not because they went to the same airlines, the same things, and they're just different time spaces, right? Same cities, same everything. So it's paired. One they got the, okay. All right. Now that I'm talking myself through this, okay, let's see. You go away. Okay, so it's a dependent samples test. So change 24.
To dependent.
Yeah, because, yeah. Okay, now I can go to the test statistic, which would be a t, and I'm getting that as 1.685.
Okay, that's what I have.
Okay, give the p-value. Okay, so open that again. Okay, they just wanted to know if there's a difference, not that it's higher or lower. So it's two-tailed, so it is 0.96. All right.
Okay, that's what I got.
All right, so which of the following best expresses the conclusion of this test? Use a level of significance of 0.10. Oh, that's interesting because isn't it kind of the same?
That is interesting.
Because if you round it, but doing
it's 0.1.
it is 0.1, it's the same. So I would say there is insufficient evidence to conclude that there's a difference in the cost of tickets purchased 14 days in advance to 90 days.
Tricky.
What do you say?
I didn't catch what you said. I
Say
lost you
that
for a minute.
my guess is there is insufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days in advance. How say you?
So the last one.
Yeah, that's what I think.
I think so too.
Because this is backwards. There's sufficient evidence to conclude that there is no difference. We wouldn't say sufficient evidence unless we're going to reject, right?
Mm-hmm.
If we're not going to reject, then we say that there is insufficient evidence because we're trying. Okay. All right. Just, all right. Hold my breath and hit submit. 96. Woohoo! Okay, where did I mess up? On the last one. Okay. They say there's sufficient evidence to conclude that there's a difference in the cost of tickets. Okay, so I guess maybe they didn't want to round.
Mm-hmm.
As if they don't round. So you didn't hit submit yet, did you?
No, it's submitting now.
Okay, I hope you.
Hopefully it submits properly and it works enough. Yeah. Okay.
All right. we're done. We got our, well, okay, I got 18 points, you got 20, but you know. Oh, you're frozen. And it's frozen on a very funny face for you, sorry. Well, since you are frozen, I hope you can hear me. I'm going to go ahead and stop the broadcast, and I will put this up if we need to put this up. And I will see you on Tuesday, and I'll start that one. And I'm talking to